QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's start with this function. Question number 1. What is the vertex of the graph of the given function? The vertex of the graph is at 1 and -1. Next question. What is the axis or the line of the symmetry of the graph of the given function? The axis of symmetry is at x equals 1. And for the last question, how many x-intercepts are there in the graph of the given function? And please tell us what are the x-intercepts. We have 2 x-intercepts at 0, 0 and 2, 0. Did you get 3/3? If not, please continue viewing this video. This video talks about the 3 important things that we can draw or analyze from the quadratic function and its graph. The first one is the vertex. The vertex is also known as the point of inflection, or the point in the graph where the graph changes its direction. So it's a point. We need to find out the x and y coordinates of the vertex. One of the 2 coordinates of the vertex could tell us exactly what is the axis or the line of symmetry. The line of symmetry, or also known as the axis of symmetry, is the imaginary vertical line that divides our parabolic graph into mirror images. And the last part is our intercepts. Now there is a separate process for that, so we're going to talk about it later. Let's start again with the vertex. Here, to solve for the vertex, we do have a formula for that. Let us do it together with understanding or considering the correct coefficients of the quadratic function. The coefficients a, b, and c follows the identification of coefficients a, b, and c of any quadratic equation. Here, the coefficient a is the coefficient of x squared, which is 1. b is the coefficient of x, which is -2. And since we don't have any constant here, our c is automatically 0. We will be using these coefficients in solving for the vertex. Again, the vertex is a point on the Cartesian plane, hence it has x and y coordinates. The x coordinate of the vertex is -b/2a. We simply plug in the values here and we will get our x coordinate. For our y coordinate, we also have this shortcut, 4ac minus b squared all over 4a. We plug in the values in this one here to get our y coordinate. But for some of us who might have problems in memorizing this one, you don't need to. This is because of the simple understanding that in any point in our Cartesian plane, once we can solve the x, we can use that x to determine our y coordinate. Our y coordinate here is also known as our f of x. So whatever will be the value of x, plug that in on our function, you will get your corresponding y coordinate. Let's start now with our x coordinate. Again, our formula is -b/2a. Our b is -2, so you have negative of -2. Please don't forget the parentheses because the formula allows us to have negative of b, and b is already a negative, so we'll have double negative property here, over 2 times 1. Our x coordinate now would be +2 over +2, or in short, it is equal to 1. This is the x-coordinate of our vertex. In our attempt later, we will see that this is the x-coordinate where our graph changes its direction. To solve for f of x or y, again, you can use the 4ac minus b squared all over 4a, but you can just simply plug in the value of your x in this function here. So you will have f of 1. So this is 1 squared minus 2 times 1. So you'll have 1 squared is 1 minus 2. So our f of 1, which is the partner of 1 being x. Here, f of 1 is our y. It's negative 1. This would mean that the vertex of the parabolic graph of this function is at 1 and negative 1. So we are not tasked here to draw a graph, but let's just try to emphasize or illustrate it with the use of the graph. So of course, this is our horizontal axis. That's automatically our x. We have here our y-axis, or again, in function terminology, this is our f of x. So if we are going to plot the point at 1 and negative 1, this is our vertex here. Now, let us try to sketch a sample graph of this. Again, this is not the part of this video, but just for illustration. Since our a coefficient is positive, and we know that in our previous video, you might want to review that one. If our a coefficient is positive, our parabolic graph is opening upward. Its concavity opens upward. So this is a sample form, or let me do it again for a better again, of course, we need at least 5 points here to really see the parabolic graph, but just sketching that one for better emphasis. So from here to there, it goes down. Once it reaches our vertex, that's the point of inflection, we change the graph, changes direction, it goes up. Now, let's proceed to the second concern of this video, the axis or the line of symmetry. The axis or the line of symmetry, as mentioned earlier, is the imaginary vertical line that divides this parabolic graph into two mirror images. Okay, so this is where we will see your axis of symmetry. Because from here, when you cut the parabolic graph, you will have this portion and that portion. If my graph is accurate, they must be mirror images. Okay? But of course, as mentioned, we were not tasked here to draw a graph. How can we determine the axis or the line of symmetry given the vertex alone? Notice our line of symmetry is a vertical line. According to grade 8 concepts, specifically on equations of a line, if our line is a vertical line, it is actually structured as x equal to something. That something there is a point on the x-axis where this vertical line intersects, and it's here. Okay, so how do we know the equation for the axis or the line of symmetry? Since it's x going to our vertex, this is the value. The x-coordinate of your vertex contains your axis or line of symmetry. In short, the axis or the line of symmetry for this function is x equal to 1. Similar to this, x equal to 1. So even without the graph, even without illustrating the idea of the axis of line of symmetry, once you get the x-coordinate of your vertex, that's automatically your axis or line of symmetry. As you can see, this is the axis of symmetry. It passes to this point, which is it corresponds to x equal to 1. Okay? Now, let's proceed to the last concern of this video. We are going to talk about intercepts. Intercepts, or in this case specifically x-intercepts, are portions or regions on our x-axis where the graph intersects. Without even just by understanding what the graph is, we know that the parabolic graph passes through the x-axis at this point and this point as well. So there are two intercepts there. So you can say that there are two intercepts already. But this is done when you have a graph. It's easy to look at the intercepts because, again, as to look at the number of intercepts, not necessarily the point itself. So, but on the graph itself, you can see that since it intersects the x-axis exactly 2 points, then you have 2 intercepts. Now, what will happen if we don't have any graph and we don't have time in graphing or sketching the graph of our function? Here's the hint. The number of x-intercepts is equal to the number of roots our quadratic function has. So the goal here is to look for the roots. Okay. Now let's take the right hand side of our function, x squared minus 2x, and we equate it to 0. Once we could determine here the number of roots, even without the graph, automatically we can determine the number of roots. But here's the big question: which is faster, sketching the graph and determining the number of intercepts, or finding for the roots and determining the number of intercepts? Now it could go both ways, but this roots here also have another meaning. Take note that our intercepts are also point in our Cartesian plane, so it's not just enough to declare that there are 2 intercepts, because we need to also determine what are they. So this is where the roots will come in. Now, according to this, in our previous discussions, you might want to review some of the videos in solving for roots of quadratic equations. This has no C coefficient, because C coefficient here is 0. If you have something like this, you can always use the common monomial factoring, x, then it will have x minus 2. As we take out x on both terms, because x is found in both terms, we will have this idea. We are using here the common monomial factoring because this has no C coefficient. Okay. Now after this could only be true. This could only be equal to 0 if one or both of them is equal to 0 according to the zero factor property or the zero product property. This is only true to be equal to 0 if the first factor, x, is equal to 0, or the second factor is also equal to 0. Out from here, we already determined one of the roots, and the second roots here is actually positive 2. So there are 2 roots now. It matches the idea that there are 2 intercepts, as there are 2 intersections here. The next question here is, what are those intercepts? As mentioned, the intercepts are points on the Cartesian plane, and therefore it also has x and y coordinates. And since they are considered to be intercepts, a point on the x-axis, always, all of the time, the y coordinate is 0, in which is to be paired your roots here. So 0, 0, and then 2 is 0 here and here. So these are now the roots, these are now the intercepts of our quadratic function using the concept of the roots. Now all of these 3 things covers the QuadQuiz this time, and it discusses how do we solve the items for this QuadQuiz. Subscribe now.